looked at the Arduino and the relay shield and how they functioned together with the code. Today, what I'm going to do is put it in this enclosure, which I've already done off camera, just to see if it fit all well. But I'm going to try to perform most of the remaining work on camera. Sometimes it's kind of hard just to make time for it, but I'll do my best to record as much information about this as I can, because I think this can be very useful for others. So let's go ahead and get started. The first thing I'm going to do is remove this cover so that you can see how this enclosure works, and there will be a link for this enclosure in the description down below. So let me go ahead and take this cover off of there. So now go ahead and remove the cover, and you can see here it has this gasket that it includes in the package that you have to squeeze into this channel. But this does not make it waterproof. It's only weatherproof, so it'll keep bugs out and it'll keep dust for the most part, but it will not keep water out if submerged. So now this could probably handle some rain. Where I'm gonna have it, it'll be covered. So I'll go ahead and set this aside. And this is the enclosure. So I'm going to try to take as much out of here as possible so that we can see how to place everything. And you'll see the way it is right now. This is the radio receiver, the RF receiver. This is a relay shield, and beneath that is the Arduino Uno clone. So I'll go ahead and take this stuff out, and then we'll look at the rest of it. Alright, so when moving these shields around, you have to be very careful to not bend any of these pins, because they do have to align with Arduino. So I'll go ahead and put it face up here so those pins don't get damaged. And this is how I've laid everything out. And you'll see here, I didn't have to cut any of this. The way this is shaped, it has an opening to allow wires to come into one side and exit the other side. And that's the way I've placed it, and that makes a perfect opening for the data port to be available in case I ever need to plug into it. And I'll show you with the data cable. And now I can plug into it to do some programming. So now that we know where everything goes, you can pretty much see I didn't do any measuring. I just put things where I felt they went best, and it turns out to fit pretty well. So I'm going to go ahead and drop the shield back in there. And always be very careful with these pins. Make sure everything feels like it's moving smoothly and you're not having to apply too much pressure. There we go. The shield is in there nicely. And now I'll go ahead and place this just to make sure I'm making room for the hole that I'm going to make. So now this fits in there. And then this cover, I only fit the cables around it. So I'll actually do it this way so you can see how it'll go. The receiver will go in here. And we'll have one cable coming out to this side, the other one out to that side. And now it can all snap together. So now this cable came off of a 9-volt charger, and I'll put a link to one of these in the description below, but I did have this one here at home. So now that I know I have to make an exit for this cable, there's also going to be a Cat 6. And this, I had it laying around here, and I'm just going to cut a piece off of this that I have to make a hole here in the side of the box. And then to protect the box and the cable, I'm going to be using this assortment of grommets to pick out a grommet that fits best for that application. And I got these at Harbor Freight. So now that I'm going to work on the cable, what I've done is I cut a short piece of this Cat 6 so that I can put it side by side with the power cable and find out what grommet works best. All right, so here we go. That looks to be pretty snug. It leaves just a little bit of light, and that's going to be fine. So let me go ahead and get all of this out once again so I can start marking the hole and drilling. All right, now that I've gotten all of the guts out of here and just left the primary stuff that's stuck on there, I'll be able to measure here and mark where I want to drill. I know that I want the cable to enter through this side right about here, just to stay away from where the cables are coming out right here. Also to keep the data port area clear, so that if I need to do some programming on this Arduino in the future, I'm able to access the data port. So I'm going to make the entry on this side. So I'll go ahead and measure here in inches, and that shows me 1.5 inches. Then I'll measure in centimeters. Shows me to have 4 centimeters, and that's going to be 2 centimeters right there. All right, now I can look at it and see if I'm comfortable with that, and if it's going to run into anything, it looks like it'll work just fine. And for pilot, I'll use a 3/32. There we go. And now I'll go ahead and put it on the chuck. And make sure that wherever I'm putting it, it's not going to extend far enough to damage anything. So I'll actually bring it in a little bit. So now I'm going to go ahead and mark it with the center punch, but I'm not going to push it until it pops because it will likely break this plastic. I just want to make a little divot here so the drill bit's not walking. So now I can go ahead and center that drill bit. And again, I'm using a 3/32 as my pilot bit. There we go. Now with plastic, it's best to drill slow and let the bit do the work. That way you're not making a mess inside. So now I'm going to step it up a bit. To a 1/8. There we go. That's the 1/8. Get this one out of the way. Now we'll step it up to a 1/4 inch. So here we go with a 1/4 inch. There we go. So now I'm going to go ahead and step it up to the 3/8. I know with plastic, it helps sometimes to put the drill in reverse just to get it to break free. It'll try to walk the little bit of a thread sort of that it makes. Now this bit, as you can see, I would definitely damage stuff if I get carried away. So I'll be very careful here. There we go. So putting it in reverse helped unclog that hole and break some of those burrs free. So now I'll go ahead and push the trash out of the way. And I can go ahead and put up this drill bit. Alright, now that the hole is made, you'll see that I have a few burrs in here that I need to clean up. So I can do that with either a utility knife or a file. whatever works best without damaging anything. I'm going to try using a file first. If that doesn't work, then I'll go ahead and use a utility knife. See if this works. All right, this may take a little more work. I'm gonna go ahead and clean this up and I'll be right back. So now that I've removed these burrs and I cleaned the mess out of here, I went ahead and filed these corners so that way over time this won't damage the grommet. As far as getting the grommet in there, there's really no science to it. It's just muscling it in there. So do it however works for you without damaging it. So I'm gonna go ahead and push it in there from the outside so we could get somewhat of a good view of it here. And because I'm going to try to keep it in frame the whole time, it may take a little longer, so I'm going to speed this up. So once you've gotten it pushed in to the hole, just take a smooth tool and try to push it up against the sides to get it to open up to its inside diameter. So there we go. And now we'll go ahead and test fit once again. First I'll bring in my smaller wire. Then I'll bring in my Cat 6 and see that I'm not going to be crushing anything. So they fit well. They can both move in and out without getting damaged, and it doesn't feel like too tight of a fit. So now that I'm going to bring the Cat 6 in here for termination, I'm going to go ahead and put everything back in the box the way it will go so we can route wires around everything. So again, being very careful that I don't bend any pins. Everything went in well. And now I will go ahead and put in my receiver, but this time I'm going to feed the wire outside of the box. So I decided to pause for a little bit and go back over how I've terminated this receiver so that maybe it'll help you not struggle with this part. So the way I've wired it is this long piece is going to be my incoming power from the battery. So it's coming into here where it says V, negative and positive. You can see those two going in there. Now I've made a jumper from positive going to common on the relay. So you see it jumping from positive, let me focus here, from positive over to common. And now on the normally open side of the relay, I've put the power going into the Arduino, and the ground is going to the battery ground. So that's how this is wired. Now let me get it all tucked away in here so that I can start bringing in the Cat 6. So there we go. Now the relay is all installed. It's plugged into the Arduino, and we have our power wire coming out to the battery. So now I'm going to bring in my Cat 6, but before I bring it in, I'm going to strip enough to reach even to the spare, and then I can roll it up in here for later. So that way everything is routed in here to where it's not going to interfere with my data port. So I'm going to go ahead and start stripping right about here, and I'll have all of this excess to play with for terminating. And for this, I'm bringing it around to the other side. So what I do is I just give it a score, and then I break it by folding the cable around. And there, now that should come off, twisting, and make sure you haven't damaged any of the conductors. So now I'm going to go ahead and get rid of the excess filler and divider that's in here, and the string, the pull string. Alright, so now before bringing the cables in, I'm going to go ahead and identify what each pair is going to be assigned to. And I've written it down here, so I'll put it in the comments as well. But for now, I'll just go ahead and call it out. The orange pair is going to be for the ignition circuit, so that will be relay 1 right here. The blue pair will be for the choke actuator. That will be for relay 2 right there. The color green will be for the start, and that will be here in relay 3. And brown will be a spare. Okay, here they're coming in. Now I'll go ahead and get the insulation in a little bit, then bring in some heat shrink that I have already separated here, just to make it look nice and uniform at the entry. Okay, there we go. And now go ahead and shrink it. Let that cool off. And now I'll bring it back down to where it's going to stop. It'll be right about here. And now we can start terminating. So for terminating, because I'm right-handed, I'm going to go ahead and flip it all around. That way I can work with my right hand for stripping the wire. There we go. So here's my guide. That way I know which pair is going to do terminate to which relay. And one thing that just occurred to me that I hadn't bothered mentioning is how I found which terminal block goes to which relay. And that is by going to the QR code that is on the back of this box. So when you get this Key Studio KS0251 relay shield for the Arduino Uno R3, you go to this QR code and it's going to take you to the wiki page for this shield, and it tells you where everything goes. So let's go ahead and get to terminating and see how well this goes. So I'm going to start with the brown. Go ahead and twist it out of the pair. Go ahead and give it a little offset here. Try to give it a nice presentation as well. And I'm going to go ahead and let's see, what am I going to do with this one? Yeah, I'm going to go ahead and terminate it to the normally open. just because that's how they're commonly used. And I'm going to be using solid as common and stripe as my contact for the relay. So I'll go ahead and bring that in. Got them right about there. Actually, I don't want them resting against the wall. So I'll go ahead and strip these a little bit. All right, so now our common will be the solid color. Go ahead and bring that in. Make sure you're not pinching the insulation. You're actually pinching the conductor. And give it a little tug. Make sure it's in there. And now for the second one, it's always nice to have some needle nose pliers. There we go. So now second one is going to be, which is going to be second from the last. So in number 3, we're going to go ahead and grab our green for the start relay. So I'm going to follow this same offset and just make it turn a little earlier, right about there. Cut it right about there. Now separate these. And again, my solid is going to be common. Go ahead and take a little bit of insulation off of there. So now I'll go ahead and put solid in the common. And this is going to be for the start. We go into the common. A little tug test. All right. Now I'll bring my green white, put it into normally open for relay 3. Now again, just center that terminal block and straighten out these wires a little bit. All right, now that the Cat 6 has been terminated inside of this box, I'm going to go ahead and cover it up, and then we'll follow this up with the test. And there we go, everything is nicely protected in there by this grommet. And in the entry, you'll see it'll take quite a bit of work for anything to get in there. Mostly if it's going to be mounted vertically like this. So now that I've gotten the box all covered up, I also went ahead and secured the wires. And I left the power wire stripped so that we can go ahead and test it. And for testing it, I'll be using this 7000 milliamp 3S battery. And I'll go ahead and connect that. And now I can set the battery aside. But you'll notice the board isn't doing anything yet. And that's because now I'm giving power to the RF unit. And the RF unit is holding that power and not distributing it to the Arduino because I need to push this button so the relay can close here. So now what's going to happen is when I push the button, since this RF unit is set to toggle, it'll go on with one push and off with another push. And when it turns on, it's going to deliver that power that it's holding through this plug into the Arduino. at which point the Arduino will begin its script, and that will start working the relays. And it'll either go to sleep based on the script, or I can turn it off at any given point. So now, like I did with the first test, as soon as I initiate the Arduino and let it start working, I'm not going to interrupt it, and I'll just let you watch. So here we go, one push. So that was the whole script, and you'll notice a little glow right here that's a reflection from the Arduino, showing that the Arduino still has power, but in the script it has been told to go to sleep. So now the relay shield isn't doing anything, and the Arduino is just on standby. So now I can go ahead and power off the unit, and there's no power being delivered beyond the RF unit. So now I'll just simulate an interruption. Let's say I want to turn off the generator once it's running. So I'll go ahead and let it start. And now it'll turn on the ignition, actuate the choke, crank the engine, stop cranking, open the choke, and now the generator is now running. So if at any point I want to turn it off, I just hit power, and the engine shuts off. So that's what it's going to stop at today. I will continue next time breaking down the generator and looking inside the panel of the generator to start testing where this is going to terminate. Because at this point I haven't really gone into the generator. I have studied the schematic for it, but now I need to physically open it up and start testing with the multimeter where all of these wires are going to terminate. So this should be exciting. I'm very excited about it, and hopefully this will work pretty soon. So stay tuned for the next video. Thank you for watching. Please like, share, and subscribe. And I'll see you on the next video. And this. So now I've hooked up the power strip.
Bought it for $75.
And then we'll just make the transfer.